Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 15, 2025, about 1 week ago. The standout idea is a single-stage guess-think-answer training recipe that pairs supervised fine-tuning for the first guess with reinforcement learning for the reasoning and final label, delivering faster convergence than pure reinforcement learning and higher accuracy than pure supervised fine-tuning. The paper is titled GTA, Supervised-Guided Reinforcement Learning for Text Classification with Large Language Models. And the implications for model training are quite significant. The authors also report strong weighted F1 on multiple datasets and show stability through gradient conflict handling. Alright, the previous segment introduced the motivation and setup. Figure 1 presents the guess-think-answer prompt flow, which structures outputs into an initial guess, a reasoning span, and a final answer so training can supervise the guess while reinforcement learning shapes the reasoning and the outcome. The left block shows text going through a prompt into the model, and the center stack shows the 3 tagged segments. The right example illustrates the format with a guess tag, a think tag containing rationale, and an answer tag that may match or correct the guess. So, the previous figure outlined the guess-think-answer flow. Figure 2 shows how training targets different spans, which matters because the two objectives would otherwise clash. The SFT row masks everything except the guess content, so cross-entropy only steers the first label. The RL row masks the guess span, so rewards shape the think reasoning, and the final answer format and correctness. This split lets supervised guidance accelerate exploration, while reinforcement learning improves decision quality. Okay, the previous figure contrasted supervision and reinforcement learning spans. Table 1 summarizes the datasets used, which matters because class count and sample size affect difficulty and convergence. The table lists SFT5 with movie review sentiment, Amazon Intents with 18 classes, the Emotion Tweets with 6 labels, and BBC News with 5 topics. Training and test sizes vary widely, so comparisons later should account for data volume differences. Well, the previous segment covered dataset scale differences. Table 2 presents head-to-head results, and the pattern is clear because GTA leads in accuracy and weighted F1 across models and datasets. Qwen 2.5 jumps to about 98.5 on BBC News, and Qwen 3 reaches roughly 92.9 F1 on Emotion. Llama 3.2 also benefits, hitting about 93.3 F1 on Emotion. These gains indicate that supervising the guess while rewarding the think and answer reliably lifts the ceiling. Alright, the previous table highlighted broad accuracy gains. Figure 5 shows convergence dynamics, which matter because faster reward growth signals more efficient exploration. Across SFT5, Amazon, and Emotion, the blue answer and green guess curves rise above the orange GRPO baseline, and they stay higher as steps increase. The gap is largest on SFT5 and Emotion, while Amazon converges quickly, yet still finishes with a GTA lead. Wrapping up, 2 takeaways stand out. The guess-think-answer structure pairs supervised guidance on the first guess with reinforcement learning on reasoning and the final label, so training converges faster and reaches higher accuracy. And the gradient conflict handling keeps the mix stable. The broader implication is practical, scalable reasoning without annotated chains. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.